Hi everybody, today we want to talk about equations and more significantly systems of conic sections. Now if you think back to when we talked about systems of equations, we were looking at two equations, linear equations, we were looking for their points of intersection. So to solve a system means to actually find points of intersection. So before I actually go about how to find those points of intersections, I just want to look at our conic sections and how they could possibly intersect. So first of all, we've got four conic sections that we've talked about. We've got parabolas, circles, ellipses, and hyperbolas. So if I take these four conic sections and I kind of start, that wasn't what I wanted to do, and I kind of start thinking about how they would intersect with a line, just a line, not with each other, but just a line at first. I could have a parabola that didn't intersect my line at all. I could have a parabola that intersected at exactly 1 point or 2 points. So just talking about intersecting with a line, parabola could have 0 points of intersection, 1 point of intersection, or 2 points of intersection. Circle, well, we could still have 0 points of intersection. We could have 1 point of intersection. It could barely touch our circle. That would be called a tangent line. Or we could have 2 points of intersection. So again, we've got 0, 1, or 2 points of intersection with the line. Ellipse is going to look pretty similar to a circle. 0, 1, 2, and there, of course there's many different possibilities for each of those. It's not the only line that could have 0 points of intersection or 1 point of intersection or 2 points of intersection. But just kind of showing what's happening here. Okay, now let's see about our hyperbola. Well, there I've definitely got 2 points of intersection. The question now is it possible to have 1 point of intersection? And the answer is yes. Very similar to what we had with our parabola, circles, and ellipse. It could just touch. If it goes through, though, we might run into some problems. It gets to be pretty difficult to get 1 point of intersection, but it is possible. Okay, if we're outside of that asymptote. Or we could have 2. So again, we could have 0, 1, or 2 points of intersection. Okay, now looking at how conics can intersect each other. Well, if I've got a parabola, just rough sketches today, so far anyway, and I've got another parabola, they could intersect at 2 points of intersection, 1 point of intersection, or not at all. So two parabolas could intersect 0, 1, or 2. How about a parabola and a circle? And I'm going to generalize, and I'm going to say circle, ellipse would both be kind of falling into the same category. So first of all, they could not intersect at all. They could just touch and intersect at 1 point. They could intersect at 2 points. They could also intersect at 3 points, if we're just touching down here at this bottom side, or they could actually intersect at 4 points. So parabola and an ellipse, or parabola and a circle, 0, 1, 2, 3, or 4 possible points of intersection. All right, what about a parabola and a hyperbola? Here's my parabola. Maybe my hyperbola looks, let's get a different color in here for my hyperbola. Maybe my hyperbola looks something like this. Not a very good hyperbola, but looking there, looks like we'd have 1 point of intersection. We could definitely have, oops, that's not what I was hoping for. We could definitely have 2 points of intersection, something like this. We already saw where I moved it at first there, we could have 3. Well, and depending on how we turn this hyperbola, we could also have 4. Let's see if I could get that drawing in here. Let's make my hyperbola open vertically up and down, and let's make my parabola, excuse me, open horizontally, something like this. So there's our 4 points. So 0, 1, 2, 3, or 4 points of intersection for a parabola and a hyperbola. And that kind of goes on. You can imagine with a circle and an ellipse, we're probably going to be able to have, and let's go with an ellipse. We could have 0, we could have 1, we could have 2, we can have 3, or we can have 4. Two circles, a little different though. There's one circle, there's two circles. Two circles can intersect not at all. 1 point, 2 points, but after that it gets pretty tough to try to get 3 points unless we end up with actually infinitely many points. So two circles, 1, 0, 1, or 2, and so on from there. So just kind of looking at how our different quadratics can intersect, and we'll come back with how we actually find those points of intersection with the next